For the construction of DC machine, we are going to see a figure. This figure will work both for DC generator and DC motor. There are basically two parts in the machine. One is rotor and another is stator. The inner part is the rotor part because this is rotating, and the stator part is the outer part, and it is attached to the yoke of the machine. Okay, the stator part is the stationary part. Okay, we supply DC in the stator part through winding, so electromagnetic flux will generate in the stator part, the outer part, the pole part. Okay, this is called the winding. This winding attached to the pole part, and the stator and the rotor part. When there is armature winding, this armature winding get rotated. When get rotated? When the rotor is going to rotate by any prime mover. Okay, when the prime mover is rotating, the shaft is rotating and the rotor part is rotating, hence the armature conductor in the slots are getting rotated. Okay, this is armature conductor cuts the flux, so a electromagnetic induction, so a electromagnetic force gets induced. That is the main thing how a DC machine works. And another thing is that depending upon the size of the machine or our requirement, the pole can be increased. So whenever the pole is increased and uniform flux distribution get occur inside the machine, so we get a better result. Okay, but we have to think one thing, that the poles are actually attached in a way such that the north pole, the south pole are getting organized in north, then south, then north, then south, in this way. Okay, the armature core, actually the rotor part where armature core is situated, the armature core is laminated to reduce the core loss. We have to know about it very well. They may ask you in the Viva board, or it may comes as a question in the exam, that why the armature core is laminated. Armature core or the rotor part, in the rotor part, armature core is laminated to reduce the core loss. Slots are cut on the outer periphery of the armature core as shown in the figure, and various coils of armature winding are placed in the slots. And one more thing, we have to know that one more function of the armature core is that it provides low reluctance path. Okay, the armature core, which is situated in the rotor part, provides low reluctance path. Since we know that DC supply is provided through a terminal box and creating north-south poles in the winding of the stator part, and corresponding flux are generated, and this is flux are cut by these armature conductors when they are rotating. And also if they ask you how many type of windings are there for DC machine, there are actually two types of winding. One is lap winding, another is wave winding. Okay, the lap winding, you can see that every winding is lapping to the other winding. Okay, that's why it is called lap winding. And the wave winding, it looks like wave, so that's why it is an wave winding. So how many windings are there in DC machine? There are two types of winding. One is lap winding and another is wave winding. And the end of those coils, lap winding or wave winding, are connected to the commutating winding. Do you know what is commutating part of the DC machine? And why do we use this commutating part in the DC machine? Actually, commutator converts the AC current, I mean the alternating current, to unidirectional current or DC current. Commutator converts AC current to DC current. That's why we use commutator in DC machine. Actually, do we know that the induced electromagnetic force that we get from while the rotor is rotating and the armature conductor is collecting the current, how they collect current? When the rotor rotates, the armature conductor cut flux, the flux that were produced in the pole, okay, and that pole were supplied by a DC supply, and DC supply, that DC supply on the stator part supplying current to the pole, and that's why there are some electromagnetic flux, and that electromagnetic flux are there. So whenever we rotate the armature by means of any prime mover, this is the shaft, okay, this is the shaft. When the rotating, when it is rotating, the armature conductor cuts the flux from the pole, okay, and that commutator collects the current, and this converts the AC current to DC current. You know, this is the actually commutating part. It is placed in the rotating part, okay. Earlier we have said that there are two type of winding. One is lap winding and another is wave winding. So the two ends of the winding, lap or wave winding, are actually connected to the commutator segments, two part, see, and there are a carbon brush connected. We will come into the later. The carbon brush collects the currents and actually do the final work to convert AC to DC. So before that, we can talk about the mica insulation. In between two segments of commutator, there are actually mica insulation. Okay, it is important. You have to know that there are mica insulation. Commutator segments are made up of hard drawn copper, very hard drawn copper due to high conductive nature. Okay, and these commutator segments are actually placed in the rotor part, and there are some carbon brushes. Actually, these carbon brushes are placed through the magnetic neutral axis. What is magnetic neutral axis? Let me tell you. So before going to the magnetic neutral axis, we can talk about the construction. We know, just a rough draw. I'm going to, this is the stator part, and let's say this is the pole part attached in the stator, and this one is the rotating rotor part. Okay, so magnetic neutral axis is that between, this one is north south. Magnetic neutral axis is this actually, where there are no effect of north pole or even south pole. This axis is actually called the magnetic neutral axis. And along this neutral axis, we have carbon brushes, from where we collect the alternating current to convert it to DC. Okay, sorry, my camera maybe not came into the proper way to show you the draw. This one is the stator part. These are the pole, north south. This is the neutral axis, where there are no effect on the axis, so we put carbon brushes just along the magnetic neutral axis. So we have already covered the construction of DC machine. Let's go about the classification of DC generator or motor, whatever you say. So we know there are two types of winding in DC machine. The two types of windings are, one is rotor winding, another is stator winding. Rotor winding is actually rotating part, and the stator winding is the the stationary part. Okay, in rotor winding we provide DC supply, so there are electromagnetic flux in the rotor winding, and in in stator winding we have shaft, and we rotate it so that the armature flux can cut the flux from the rotor winding and have an induced voltage in it. Okay, there we have field winding in rotating part, and there we have armature winding. Now, talking about the classification of DC generator or motor. So DC generator, basically there are two types. One is separately excited DC generator, another is self-excited DC generators. But the self-excited DC generator is basically can be divided into three parts. What are the three parts? DC shunt generator, DC series generator, DC compound generator. And this DC compound generator again can be divided into two parts. One is cumulatively compound DC generator, another is differentially compound DC generator. In separately excited DC generator, if the field winding excited by a separate DC source, then it is called separately excited DC generator. There is no connection of external DC source being utilized to excite the field winding with the armature EMF. If field winding is excited with the help of armature EMF, that is self-excited DC generator. I am saying it again. If the field winding is excited with the help of armature EMF, if the field winding excited with the help of armature EMF, that is self-excited DC generator. Okay, the basic difference is that in separately excited DC generator, field winding is not connected to the armature winding, but for self-excited DC generator, field winding is connected to the armature winding. Do we understand? Actually, the field winding, we know that the field winding is in the stator part. So the basic difference, again I am saying that if the DC generator's field winding is not connected to the armature winding, the rotor part. This part, if it is not connected to the rotor part, then it is the separately excited DC generator. But if this part is connected to the stator part, then it will be a self-excited DC generator. And as we know, there are three types of shunt, series, compound, and compound can be divided into two, cumulatively and differentially compound DC generator. That's all. And lastly, I am really sorry because my English was very bad, but I am trying my best. Okay, thank you.